Standard agricultural textbooks are excellent at teaching students how to run calculations. They are terrible at teaching what happens next. Modern agriculture presents a genuine tension. How do you maximize food production while shrinking your carbon footprint? There is no single correct answer. Every lever you pull creates a cascading side effect somewhere else in the system. Students can read about these trade-offs in a syllabus, but a lecture can't make you feel the weight of a bad call. To truly understand the stakes, they need to live with the fallout of their own decisions. Enter Dr. Christopher Teh Boon Sung at University Putra, Malaysia. To close this gap, he designed 2 high-stakes agricultural simulation games. You cannot cheat these simulations. Every scenario is seeded by the student's unique university ID number, which generates custom weather patterns and market prices. Copying a classmate's homework is mathematically useless. You have to face your own choices. Game 1 is called Plant the Right Day. It is a simulation of rain-fed rice farming in tropical Malaysia. This diagram shows a chaotic 240-day weather forecast. Students have to look at this noise and choose a single day to drop in a 120-day crop cycle. The goal is to slide this window so that the crop's highly vulnerable reproductive stage, this highlighted section right here, lands perfectly inside the wettest weeks. A drought during this exact window ruins the harvest. One student scored an 84% by generally aiming for the wet season, but their calendar arithmetic was slightly off. They accidentally dragged the most vulnerable window right into a dry spell. This is where the game introduces an AI tutor powered by Claude. It reads the specific data from that unique student's run, spots the exact counting error, and explains exactly why the yield dropped. Armed with that concrete correction, the student faced a second highly erratic weather sequence. This time, they did the math right, protected the reproductive window, and scored a 98. Here is the brutal trade-off. You need heavy fertilizer to hit your yield targets, but push too hard and nitrous oxide emissions spike. You fail your pollution audit and instantly lose the certification. This graph tracks a student who faced a sudden debt obligation right as market prices crashed. They panicked. They pumped up inputs hoping for a quick revenue boost. But because of the 12-month lag, the yield didn't materialize in time, and they drove the estate into bankruptcy. Zooming out to the entire class, the results are stark. Out of 35 submissions, only 4 distinct paths managed to thread the needle, maintaining high yields, healthy soil, and full certification. This low success rate captures the actual difficulty of modern estate management, where high yields and strict environmental compliance often pull in opposite directions. After playing, the students stopped regurgitating formulas. They wrote reflections detailing the actual management strategies they discovered through their own trial and error. One student accurately detailed how to scale back fertilizer during an El Niño drought and increase it the following year to prepare for the harvest. They learned the rule by living through the scenario. The human instructor remains the essential architect of the course and the relationship with a student. The AI acts as a force multiplier for that teacher, delivering a personalized, data-driven critique to every single student simultaneously, a task that is physically impossible for a single professor at scale. These games serve as a sandbox for reality. By forcing students to own the consequences of their actions, they graduate with the visceral intuition required to navigate the chaos of a changing climate.